coming to this TCORS and HEAL seminar. It is my pleasure to introduce Dr. Jason Oliver. So it's a pleasure to have him here. He is actually here because he has a K01, no, actually probably a K08, right? I should get
K23.
K23. A K23, an early career K award from NIDA to study neuroscience of nicotine dependence and also integrate that with EMA technology. And I had the good fortune of being a co-mentor on this project. So he's actually out here training with us in our lab, but we have the good fortune of actually having him give a talk to us. So we're glad that it's kind of working out for you and it's working out for us. So Jason is a very well-trained and accomplished early career scientist. He went to SUNY Buffalo for undergrad, has a bachelor's in psychology, and I saw did you have a minor in business administration or something?
Dual degree in business.
Oh, dual degree. Yeah, so that will come in handy as your research group grows. And then, so he went to University of South Florida, got a degree in clinical psychology, and he trained there, and he also cross-trained at the Moffitt Cancer Center in Tampa, Florida, doing work in their tobacco research group there. Then he went and got his clinical internship training at Yale and continued doing more research, kind of broadening the scope of what you were doing. And then he's been at Duke for a couple years now. First as kind of like a clinical associate postdoc, and successfully now getting his K. He's an assistant professor in the Department of Psychiatry in the Center for Addiction Science and Technology. And so I've known Jason for, I don't know, maybe like 5 or 6 years from SRNT, and it's really been a pleasure to watch his career grow and see him be successful. And I think he got a perfect score on an RO3, right? So I don't know, whatever you're doing, like, you know, teach us, right? And he's been very kind and been wanting to, and willing actually to share even copies of his grant applications for people. And I know Tyler, who's here, kind of wants to do a parallel project to what Jason's doing for his K. So anyway, let me give you the floor, and it's a pleasure to have Dr. Jason Oliver.
So I'm not sure if this is going to work or not. We can try it. First off, thank you everyone. Those I've met with so far. It's been quite a journey the past week. I've had a lot of meetings, gotten to know some of you, not all of you quite yet, but I was really just struck by the heterogeneity in the type of research that's being done in this department. It's incredible to see everything from the folks doing neuroscience, behavioral pharmacology work on up through sort of larger scale public health policy research. Really striking. Also makes it really, really difficult for me to try to tailor this talk to the audience. So I'm going to do the best I can with that. That said, I will, the way I decided to go about it, I'm giving the methods in this a little bit of a short trip. So happy to discuss it, happy to provide more details, either on the back end, email me. But that said, the focus of the talk, I thought it would be more helpful if we kept things kind of broad, conceptual, rather than getting bogged down in a lot of the neuroscience nuance and what whole sequence I used in imaging and those sort of things. So, with that said, Okay, so no conflicts to disclose at this point. Most of the work that I'll be talking about today has been funded by NIDA. One of my dissertation was funded by American Heart Association. We have some pilots funded from Duke Cancer Institute, and then a bunch of smaller awards from various societies, foundations. So, really my goals for today are broad. I feel a little silly including this slide. How many of the folks in the room are doing or have done tobacco research? Okay, so most, not necessarily everyone. I included the slide just as I think a helpful reminder because it's worthwhile considering just the extent of the impact that we have the potential to have in this line of research. So worldwide, we're looking at about 7 million deaths with tobacco. That includes both actual use and then secondhand smoke. And when you compare this to other things that are considered enormous public health crises, and there's tons of funding for, and everyone's really worried about it, it's really striking. So, we add on. So AIDS, about 1 million people a year. Tuberculosis, well, okay. I'm just going to drop this thing. So tuberculosis, about 1.3. Malaria, about 400,000 a year. Traffic deaths, about 1.25 million a year. Suicide, which we're hearing a lot about in the news now, takes about 800,000 people a year. Homicide, murders, about 450, 500,000 a year. And when you make this comparison, even summing all those together, we're still not reaching the amount of, the number of deaths, the amount of harm that's caused by tobacco. And this is, again, really striking worldwide numbers. And one thing that I think is easy to forget about where we are is that that number is actually still going up. I'm projected to hit 8 million by 2030. We've had a lot of very effective public health campaigns in the US, but I was just in Eastern Europe, Armenia, about 2 months ago. Smoking rates there among men vary between 50 and 85%, depending on which study you're looking at, the exact methodology that they used. There's other countries with even higher smoking rates. So it's still very much a very serious problem, even here, but even more so in other parts of the world, where tobacco control policies, cultures, everything else may be contributing in very different ways. Okay, so jumping in kind of the meat of the talk, I'm first going to start with just some brief history. Spent a little bit of time talking about the rat park studies that I know some of you may know well, others not so much, but they took place in late 80s, and the basic gist behind these was, you have sort of the traditional laboratory setup there in an animal lab. We've got, 40, 50 rats in cages very much like that. And, when we typically assess drug use and drug taking behavior in rodents, they get the lever, they press the lever, they get cocaine, nicotine, alcohol, whatever we might be trying to assess. So, Bruce Alexander ran this study that's, on its face, it's remarkably simple. It just said, okay, well, this is how we've normally been housing rats. What impact does that have? What if instead of that, they get something a little bit more like this? So you can see they have trees painted and basically a whole little play area. And what he found was that rats didn't really take much of the drugs at all in that setting. But the environment had a really profound influence on drug use and drug taking in that context. Now, study had some problems. Not gonna, not gonna try to say otherwise. There's questions about, was this due to the particular strains of the rodents that were being used? Variety concerns about, various potential confounds in the design. Had some success with replication. Others have struggled to replicate it since then. And it really just kind of fell off the radar after about 1985, 1990. And I think that's a shame because on its surface, I think this idea is brilliant. Why are we studying the cage? If you put a rat in a cage and the only thing it can do is press a lever and get cocaine, what are we expecting? What would result from that? So I think, and a big part of what I'm going to be talking about today is how we broaden our minds in how we approach science and how we approach laboratory research, clinical research, policy research, to take this broader context in mind. So just something I want you to keep in the back of your mind throughout the talk today. So how do I go about studying addiction? And I do consider myself an addiction researcher first and foremost. The majority of the work, and actually all of what I'm going to be presenting on today, focuses on tobacco. But I'm generally using that as a model for addiction to try to understand the underlying behavioral processes, the principles more broadly. So the approach I usually take is focusing on first the drug itself, what effects does that have, what alternatives might be available in the form of other sort of natural rewards. You think in rodent models, we're typically looking at food, sex, other social rewards. In humans, obviously, we have a much broader range of categories than that we can study. And importantly, keeping in mind, well, a lot of the work that I've been presenting is from a cognitive neuroscience framework, understanding the role that decision-making plays in governing between these two things. You can have two rewards that are perhaps equally salient and that we know are of the same value based on whatever technical definition of value you're coming up with. But that's not necessarily how an individual is going to make a decision in a given circumstance. Long history of research in behavioral economics, understanding how and why we go about making imperfect decisions. And really, this is the overall conceptual framework that I'm going to be using to guide most of my research and all of what I'm going to be presenting today. So, goals for today, I'm going to review some traditional behavioral pharmacology cogneuro studies that we run in our lab and in some others around the country. I'm going to talk a little bit about some ongoing upcoming projects aimed at bridging the gap between the lab and the real world. My apologies with those of you I've already spoken about these with over the last few days. And then talk a little bit about, if I can, not get overly excited about the amount of findings that I've crammed into this talk, save some time at the end for just broad discussion of what this framework means for treatment, what this framework means for tobacco control policy, and how we think about and conceptualize addiction and smoking research at a very sort of broad level. So, jumping in first, how do we typically study drugs in the lab? Well, the short answer, I think, is poorly. The slightly elaborated answer, a very typical laboratory paradigm that we and many, many others have used, we compare cigarettes, or whatever other drug we're interested in, to the most neutral, boring, irrelevant stimuli we can find. So I might put someone in an fMRI scanner, show them pictures of cigarettes, show them pictures of staplers, or a pack of pencils, or office supplies seem to be a theme for whatever reason. And look at the effects that it has on the brain, look at the effects that it has on behavior. We may measure reaction time, depending on the type of task that we're doing. Lots of different things that have been studied in this way. And what kind of results do we see from this? Well, the guy I worked with at Duke ran one of the earlier studies looking at effects of nicotine withdrawal within that sort of paradigm. And you do see brain lights up in various different regions associated with cognition, reward, decision making, those sorts of things. And that's amplified. That response is amplified during withdrawal. So again, interesting, I think, and there's obviously tons of value in doing this type of work early on. There have now been between 15 and 20 studies in this area, meta-analyses coming out, sort of honed in on some more reliable findings. Huge issue within neuroscience more broadly to try to figure out exactly how to go about that. Definitely having a replication crisis there as well. But that said, some areas where we are seeing reliable findings, superior function gyrus, linkable gyrus, in terms of the effects of withdrawal. Also been some studies trying to link this a little bit more with kind of the traditional outcome measures that we look at, self-reported craving, mood, those sorts of things. And again, there's certain brain regions that pop out in a reasonably reliable way. We seem to be seeing some consistency across studies. Now, I'm going to tell you briefly about a study that I did. It was actually one of the simplest designs that we've ever had. So the two previous studies I showed you were neuroimaging studies. Provide very good spatial resolution with fMRI. We can determine exactly where within the brain we're seeing the effect. This study used a different paradigm of ERP, event-related potentials. Allows you to get much, much less spatial information, but very, very fine-grained temporal resolution. So we can tell really millisecond by millisecond what's going on in the brain, but we don't have a great idea exactly where within the brain. So that's all the details and the methods that I'm going to get into for that, in terms of that. But What I want you to focus on here, I hate presenting tables during talks, but it is what it is. That's all I really want you to worry about for now, and that's the smoking status by cue type interaction. We had non-smokers versus smokers, and they were shown unpleasant cues, pleasant cues, smoking cues, and neutral cues. The exact same thing everyone else does, but we threw in 2 other categories, right? Findings indicated, okay, yeah, there's certain areas, certain particular temporal windows where we do see an effect, and smoking cues are differentially activated for smokers. Nearly the same thing for pleasant cues, at least for 2 of the 3. Well, that is pretty striking and suggests that the classic interpretations that go along with this research, which is okay. Well, we see that smoking cue effect absent any study of pleasant cues, and people interpret this as addicts have a differentially sensitized attention to drug cues. That's why they're so driven towards drugs, and this suggests that they're really not necessarily any more driven to pursue drugs at a cognitive level than they are to pursue pretty pictures of trees or other things that they're clearly not addicted to in a classical sense. So, submitting this to Health Psychology, one of the reviewers had this to say. I include this for 2 reasons. One, because I know we have some trainees in the room, and I think it's important to remember that we all get things like this. So don't be offended when it happens to you. And also because that's true. Like, my response to reviewers was pretty much that. And when we think about this, this shouldn't be a groundbreaking finding. I should not have been the first person to do this study. This work has been going on for 20 years. Why is it that the obvious questions, like, okay, why are we not using active controls? Why are we just thinking about cigarettes in relation to staplers? Of course people care about cigarettes more than they care about staplers. I care about cigarettes more than I care about staplers. It limits the amount of information we get. Again, I'm not going to get bogged down in the nuance of why. I think there's statistical reasons. I think there's conceptual reasons. I think there's just a lot of problems with approaching research in this way. But this is a huge problem in the field. And if you look at the number of studies that have used other cue types in smoking cue reactivity research, we're looking within just the folks that have done the neural work. I think there's 3 out of probably over 150. With behavioral research, there's maybe another 3 or 4 out of way more than that. This is an enormous problem. We need to do something about this. So, sort of moving on, what I'm going to tell you next about.
Jason, but the finding when you the pleasant cues, you found that the smokers had a hyper response to the pleasures cues.
Hyper response to pleasant cues relative to
non-smokers who had just like a response which wasn't as strong.
Right.
Got it.
So in terms of probing this framework a little bit, the next few studies I'm going to tell you about focus on the effects of nicotine withdrawal on cognition, the middle aspect of this model. So studies I'm going to tell you about just briefly the type of approach that we use to studying this. Folks come in for a screening session and abstain from smoking overnight. We verify that with a CO monitor and make sure that they actually did abstain overnight. Come into the lab, and then we basically just smoking cigarettes for a little time. We'll smoke anywhere from 3, 4, we've done some studies with 2. We've varied all of that across studies. It seems to not really matter. For the most part, after they've smoked the second cigarette, they seem to be relatively satiated and doesn't seem to have any effects above and beyond that, like traditional cigarettes. The critical manipulation is half the cigarettes will have nicotine in them. Half the cigarettes will have the nicotine removed, so denicotinized. And these are, we're splitting that across sessions. So basically they'll have one session where they're essentially satiated, another session where that withdrawal continues because they're only smoking the denim cigarettes. And then in between this, they're first fitted with an EEG cap, which is a little bit like that. Then we're doing various behavioral and neural tasks in between the additional cigarettes. So, first thing we're going to do is look at just overall response during at rest, where they're just sitting in a chair, staring at an X on the wall, as long as you can think of. And what we find is in two particular waveform bandwidths. Again, don't worry about the details of that. But what's important to note is the consistency. These are different electrode pairs across the bottom. And the consistency with which during deprivation, these bandwidths, signal power increases. What does that mean? Suggests that based on these two particular bandwidths that are typically activated when you're sleepy, just kind of sitting down, relaxing, not really doing a whole lot, not focused on anything. It's just that deprivation, nicotine deprivation, is essentially dulling the attention, dulling cognitive systems, making it more difficult to focus in on what you're doing. Well-known withdrawal symptom, not surprising, but this is one of the more rigorous tests of that as an actual biological marker in a fairly large sample for this type of research. The early EEG studies were typically only running this with 10, 20 people at a time. So it made it a little bit more difficult to find consistent findings like this. Now, obviously that, even in terms I was using to describe that, attentional dulling, these are not nuanced cognitive processes, right? I'm talking about something that's really global. How can we get a little bit more nuanced in our assessment of this? One of the tasks we administered was what's called an oddball task. Again, on its surface, it's very, very simple. We're essentially just presenting stimuli. We use blue spheres, and you see a bunch of them. They all look the same. Brain's getting bored and not responding in any significant way until you see a target, a slightly bigger blue sphere. Talking, a difference of, I think it was 3 versus 3.5 centimeters. It wasn't a huge difference. But when they see that larger blue sphere, they have to press a button. That's it. And they keep going until they come into this distractor state. They don't have to do anything to it, but it's there. It looks weird relative to everything else they can see. The brain separates these things out, and this P3A component, you see where there's the rapid increase and then, does not something I have to do anything about. This is what occurs in response to that checkerboard stimuli. Drops off fairly quickly. What we call the P3B is the brain's response to those targets. There's times it does have to take action. And again, not a huge, robust increase there, but it certainly elevates above the standard stimuli. And again, requires some action, requires some interaction with the keyboard, with the environment. It takes a bit longer to return to baseline. So, looking at the effects of withdrawal on this, what do we see? Looking at, with regards to target brain activity for the P3B, the response to targets, what we see is deprivation seems to suppress that. Individuals are having more difficulty attending to their environment, struggling to interact with things when they experience that nicotine deprivation. Turning to the distractors, you see a little bit more complicated interaction. This is a double difference score, which I keep doing, but it's just too much to try to put it all on one slide. But what's important here is they essentially gave self-reported attentional control scale. Completed that, and it was only the folks that had low attentional control based on that self-report measure. Things like, I have troubles paying attention when there's distracting noises around. I have troubles focusing in when there are noises in the other room. People who report greater difficulties with those things showed a greater drop from baseline. They essentially showed an enhanced response to those distractor stimuli relative to individuals who did not report impairments with attention control.
Can I clarify? You're saying that they had greater loss if they already had that tendency?
They had, it's different scores.
Or they had, more specifically, they had greater loss due to nicotine withdrawal than other people who were usually less easily distracted?
Yeah, so essentially if you have troubles paying attention and you see a distracting stimuli and you're in nicotine withdrawal, that is going to be more distracting than it otherwise would be.
Okay.
Does that clarify?
Yeah, thanks, makes a little sense.
Okay, so continuing along, I'm going to talk next about my dissertation research, which really just sort of focused on the alternatives, alternative rewards component of this framework. So first, we focus in on understanding motivational state. This was done again in a really crass way. So Richard Davidson ran a bunch of studies dating back really to the early 80s, looking at how we can understand, approach motivation using some of these neural measures. And it essentially just involves looking at differences across the electrodes at sort of the front part of the scale. Little cheat sheet there just because we're now in different score land, and I think it's easier to have some visualization of things like that. But again, what you see is a similar pattern to what we saw before. Only now we're looking at a neural index of motivation. And individuals seem to shift to a more avoidant state when they go into withdrawal. Again, not surprising. There were a few tries to do this, sort of late 90s, early 2000s. Again, some of the same problems I brought up for small sample sizes. Certainly our equipment and our ability to analyze and do this type of research has expanded pretty dramatically over the last 20 years or so. What I found really interesting, though, was who we saw those effects in. So, unlike some of the other research I told you about, where it just seemed to be robust, it was present in our entire sample, see whopping differences as a function of what people's motivation to quit is. Individuals who had tried to quit in the past didn't really show this effect at all. Individuals who had never tried to quit showed a whopping effect. Now, obviously, cross-sectional, we can't, we need to be careful about how we interpret these findings. But that said, I think this, is strongly suggestive that either those effects are so aversive that individuals are less willing, less able, not going to even consider quitting in that context, or that perhaps this is some sort of trait deficit model where individuals are just really struggling to motivate themselves in general, and maybe there may be some sort of essentially, they go with the status quo, they're more prone to depression and more prone to, not necessarily pursue behavior change in any, substantive way. So again, we can get a little bit more nuanced with this. Again, looking at the reward prediction types of tasks done by Wolfram Schultz, various others, long history of animal research in that way, we can get at essentially that that nuanced dopaminergic firing occurs when individuals are presented with a reward, and that varies based on whether that reward is expected, unexpected, whether it is a reward versus a punishment. And what we see is, again, a similar pattern to what we've been seeing, where there is a main effect of nicotine withdrawal. When individuals are smoking the placebo cigarettes, the brain is responding differently than it is relative to when they're smoking nicotine cigarettes. I want to draw your attention to this one in particular. So the normal pattern of firing we'd expect from the striatum mental area, when you're looking at when you're running studies like this, you'd expect the lowest, really a dip in firing during unexpected punishments. Not a whole lot going on when the rewards or punishments are expected, and then an increase above baseline when you're getting unexpected rewards. You're expecting to get a punishment, you got a reward instead. Especially in the withdrawal condition, that effect seems to be abolished completely. If you look at the orange bars, there's a slight increase in under the nicotine condition, but the unexpected rewards is actually a dip relative to the expected rewards. So again, suggests that there may be some reward processing deficit that's occurring within this context, within this type of work. And broaden that out a little bit to look at reinforcement learning. So, taking this immediate reward and what do we actually do with this?
Can I ask a question, Jason? Can you go back to the last slide?
Yeah, of course.
So the more the taller the bar is going down, the more
true.
Okay.
The
More
polarization.
reward processing or whatever, right?
Well, okay, so
Yeah.
in this context, the less reward processing, if you mean like the longer it is down, is that what you're asking?
Okay, I'm sorry, yeah, I see, the placebo is the orange ones,
Yeah.
right? And so if it goes down, then that means they're not processing it as much.
Correct.
And usually like when there's an unexpected reward, we're like, wow, yeah, this is great.
Yeah.
And then your brain kind of hovers above probably that zero, I would imagine.
Yeah.
Just like the people who want.
Yeah, so again, I'm not getting too bogged down in
No,
the
that's okay,
differences.
but, I'm oversimplifying, yeah, thanks.
So running quickly through reinforcement learning, this is another task where they're given very little instruction other than like pick between these two things. One is good, one is bad. You don't know which. And they just have to learn over time. They're incentivized to perform, and they're really just guessing, picking left and right. And we're seeing different pairs of this, some of which are pretty easy. One's right 80% of the time, others right 20% of the time. Most people get that fairly quickly. Some are a little bit more moderate in difficulty. Others are extremely difficult. I programmed the task, and I still have trouble with the difficult category. And we can look at the brain's response to that feedback, and again, this pattern emerges, where their response to the feedback seems to be suppressed. Again, we're talking about the feedback-related negativity, different components, but essentially, when we look at folks in the nicotine condition, we're seeing this, and relative to folks under withdrawal, their response to the feedback is dropping. Their brain is not responding in the same way, and it's basically making everything look a little bit more like incorrect feedback. I think the easiest way to understand, if we look at nicotine withdrawal and their essentially what their feedback-related negativity looks like under withdrawal, to correct response, it looks very much like what people are, how people are responding to incorrect stimuli when they're not withdrawal. Really, again, just kind of suggesting that everything, other external stimuli, appear to be worse when you're undergoing nicotine withdrawal. Again, not surprising, but different ways of getting at this question, honing in on what the brain is doing. Talking a little bit about acquisition of these stimuli, essentially how well people learn this over time. And again, a little bit overload on here, but one thing to know, solid lines are during nicotine, dashed lines are during withdrawal. And you see clearly across this case, this main effect where individuals are just plain worse at learning from corrective feedback when they're undergoing withdrawal. So, what do we take away from all of this? I just threw a bunch of data at you. I think we clearly have indication that nicotine withdrawal is enhancing responses to drug rewards, suppressing responses to alternative rewards, causing some disruption in the cognitive systems. All of those things appear to interact in some fashion. And then the findings appear to be robust across different tasks and measures that we're using, different modalities, whether we're looking at functional imaging, EEG, behavior, different subtypes of cognition, different subtypes of reward processing. We're seeing some consistency in the findings, and I think there's a lot more comfort in the fact that these might be legitimate, real findings. But they're also pretty nuanced in a lot of ways. We talked a little bit about individual differences, talked a little bit about how, when we use active controls, we might see or understand things a little bit differently than when we're just relying on these passive controls. Just takeaways. So, we'll come back to a lot of what I was talking about there in a little bit, but now we're going to talk a little bit about how we can expand this framework. My focus so far has been on kind of these individuals, this sort of low-level, basic science characteristics. A lot of our more recent work is focused on understanding how all of this, how the environment might impact this system, and how we can understand that relationship between this. So, what we typically do, we might spend a lot of our time focusing on trying to bring the outside world into the lab, trying to harness what's going on out in more traditional contexts where people might be spending. See if we can use some of these, sort of rigorous, internally valid experimental research to understand that. So I mentioned, our cigarettes versus staplers paradigm. You can see it again in this case, cigarettes versus pencils being shown in the scanner. But we also wanted to broaden this out a little bit to look at the influence of environments. So we showed people sort of standard smoking and non-smoking environments. Bus stops, very common smoking location if you talk to smokers. The gym, probably not so much. But what we also did was had them go out and take pictures of their personal places that they smoke. The loading dock behind their workplace. Not just any loading dock, their loading dock. The back porch of the house, not just some random back porch we pulled off Google Images, their back porch. And we also had them show non-smoking, take pictures of non-smoking locations, places where they never smoke. So, their office at work, their kid's bedroom, whatever it may be. If we take the traditional approach, show these things in the standards, you see clear pattern of main effects, just like what we expect. Individuals, yeah, they say I'm craving more when I look at the cigarette than when I look at the notebook paper. Again, is that just a demand effect? What that means, I don't want to make too much of that. But what's really fascinating about this is the brain can tell the difference. Specifically, the posterior hippocampus, which is associated with spatial memory, spatial processing, and the left insula, addiction, motivation, those areas reacted differently to the personal stimuli relative to the standard environments and relative to the proximal cues. So, what does this tell us about addiction? It first off suggests that there may be regions of the brain, maybe particular types of stimuli that are going to play a greater role in driving addictive behavior. Suggests that the personal relevance of the cues may really matter. And then again, our sort of stock laboratory approach of pulling standard stimuli that we show everyone off Google Images, might not be the best way to go when doing this type of work. What else can we bring into the lab? Well, we spent a lot of time recently focusing on understanding the role of tobacco retail outlets and what impact do those have on behavior, on smoking initiation, smoking relapse, craving to smoke. They vary a lot in terms of what they look like, what they represent, what they are. You see one up here that is my favorite to show during slides, as it is particularly egregious in its storefront advertising. There's not much subtlety to that particular store. But these tobacco retailers are also, any corner gas station you drive by probably sells tobacco. Walgreens, until fairly recently, CVS, most any pharmacy. Walmart, virtually any grocery store you go to is going to sell tobacco. So all of these represent opportunities to purchase tobacco and an ongoing smoker. I worry that even just walking by something like this on a day-to-day basis would normalize smoking, right? For a kid, for someone who's potentially looking to quit smoking, it'd be a lot more challenging when you're confronted with things like that on a day-to-day basis. So how can we bring something like this into the lab? What we did was rather than giving people a camera, we gave people a GPS tracker. And I should back up a little bit. Prior to giving them the tracker, we went out and drove around and mapped out every single tobacco retail outlet in Durham. Possible in Durham, I wouldn't recommend trying it in LA. We only had about 270, so it was feasible to go to all these places. Code, exactly what storefront ads are there, what products they're selling. Take pictures of all of them. We had quite the adventure of doing this. We had two research techs who got chased away by an angry store owner with a baseball bat who thought they were the health department. So not your traditional sort of research experience in making this happen. But anyways, we have that map, we have GPS locations for all of this, and we're able to track where people are spending their time. And then what we can do is we can extract that information, draw buffers around each of these particular storefronts, and get a sense of, okay, that was a tobacco retail outlet that's inside their activity space. They spent, at least a few minutes, sometimes, an extended period of time around that, sometime over the course of the 2 weeks. Do the same thing for our control stores, non-tobacco retail outlets, beauty supplies, clothing stores, anything we could find that didn't sell tobacco and sold other sort of consumer goods. and, select out the ones that they had the greatest contact with, as well as ones that they had no contact with over the course of that 2-week period, which is defined as at no point did they come within 500 meters of that store. We also had a control condition where we also showed them standard images drawn from another county that they had to report never living or working in, just for the sake of comparison. So, what do we see here? Left campus, you'll note that for the smokers specifically, again, and we know this, too many bars on some of these graphs, but ignore that for a moment, focus on smokers, and it's specifically inside activity space, tobacco retail outlets where you see the largest activation. Left Petunias, same thing, tobacco retail outlets, inside activity space, largest activation. These are, again, regions of the brain associated with, in the case of hippocampus, spatial processing, spatial memory, case of Pecunius, self-relevance, and integration of information. So,
Okay, I'm sorry, could you clarify the difference between inside and outside activity space?
yes. So inside activity space were placed the stores that they, the 12 stores that they had the greatest amount of contact with over the course of the 2-week period. Outside activity space was a random selection of stores that they had zero contact with.
So it's outside the study area, or they're
Inside
geographic area?
inside the study area, but outside where they spent their time.
Okay.
So still in their own county.
In this incident, like, you showed them the images of that, or?
They were shown, yeah, they were shown the pictures in the scanner.
better.
They were shown the pictures in the scanner. Scott.
Of those,
Sorry,
of those retail, okay.
Yep.
Can I ask a question?
Of course.
So do you have any them kind of going around their life was so that you could create this living line, kind of classify inside and outside activity space. Do you have any measure of for the the TROs that are not tobacco related, or maybe I'm saying it wrong, but basically you mentioned like the gym or other places they go. Is there a way to tease apart like the frequency of encounter
Yes.
from the actual? Okay, because it's like if they go to the tobacco shop a lot of time, all the time, and they go to like the ballet or whatever, just like once or twice, then your spatial memory is gonna light up. Same thing for me and like whatever, I don't know, going to Starbucks because that's where I do my work or coffee.
So we absolutely can do that. We're still kind of honing in on the best way to do that in terms of, you can look at raw point count, but the trackers aren't perfect. You can look at, total duration of time spent in that location, total, the number of return visits to that location. What we've seen so far, it hasn't actually shown much variation with the signal, but, again, we're still trying to figure out the best way to analyze that.
So if I understand the difference between inside and outside, in both cases, all three of those cases in county control, they're shown images. The difference is that inside activity space would be images that they're also familiar with from their personal lives?
Correct.
Okay, so there are images in all three cases, and the green lights up when it's also a place they frequent.
When it's a place that they've spent time, they don't necessarily have to go in because it's a 200-meter buffer, but it's a place that they're at least, driving by or spending a significant amount of time nearby on a regular basis.
And how do these activity spaces relate to where they actually live? Or if they're in college, where they go to college? I mean, you're defining the space in terms of where they spend the time, but part of a function, what drives that is it close to where they live? Is it close to where they park the car? Is it close to where their school is?
So I'm not entirely sure I understand the question, but I think what you're saying is just how do we account for the fact that the types of stores that they encounter may differ based on whether they live in like an impoverished SES, low SES region where those sorts of advertisements may be more common relative to let's say a higher income area where there's the types of stores that they're encountering essentially what you're getting at?
No, more, your work is implying that the characteristics of the stores that are inside their activity space, that it's something about the tobacco retail industry and the posting of the ads and so on, that's driving them to be in that activity space. But my question is it also possible that they live close by these places that happen to be defined inside that activity space, and so it may or may not have to do with tobacco retail advertising alone, it may be their proximity to that
No,
place.
okay, yeah, so I'm with you now, but yeah, that's a really good point. And I'm not necessarily trying to make the case that it's the tobacco ads or, you know, the types of stores or anything else that's driving this function. I think it could be the fact that, you know, they're responding to the stimuli differently just because they're spending more time there. We're still, you know, running all sorts of iterations of this to try to figure out, you know, are these effects different based on advertising? Are these effects different based on store type? But the critical manipulation here is where they're spending their time. And that is absolutely driven by, you know, where is their, you know, place of work, where is their residence. And there's, unfortunately, with this, you know, type of design, there's no way to randomly assign people to, you know, a home on this end of the county and a home on that end of the county. So we're just sort of, this was a pilot study, just kind of coming in with what they, you know, what they gave us and figuring out what, how the brain response is going to differ as a function. So some take homes here, personal relevance seems to matter, environment seems to matter. Starting to think about ways we can intervene more directly. Could we apply some sort of exposure therapy intervention to the stores? Could we apply an exposure therapy technique to to smoking environments? Already have some pilot data on that. Looking at different pharmacotherapies, looking at different policy interventions that may allow us to target this more a little bit more directly. Immediate future directions. Two different directions that I'm taking are really both lines of work here. First is the one I'm going to focus on after this talk. Looking at understanding the effects of nicotine withdrawal on reward, and again, trying to focus on bridging that gap between the lab and the environment. I'm not going to talk really much more about the second study, though I'm happy to if anyone's interested. But it's essentially looking at drug manipulation tacked on to that study I talked about briefly, showing differential brain responses to smoking versus non-smoking environments. So this study, at Kid 23, essentially what we do is bring people in for a baseline session. They're going to fill out a questionnaire about different things that they might find enjoyable. So this is a very abbreviated version. It's actually like 300 items long or something like that. And they might say, okay, don't really spend, I'm not really doing a great job at worker classes. I do spend a little bit of time daydreaming about my life. I do kind of enjoy it when I do. But as they go through this, what we do, we then pick out the items that they have the strongest responses to, or the highest response to. Essentially what they're experiencing the most reinforcement from. And this time, we're going to send them out to take pictures of those things. So let's say they responded, favorite things to do, getting out into nature, cooking, eating out at a restaurant. Those are all the things that they really enjoy, but they don't associate with smoking.
Is that independent? Oh wait, yeah, sorry, you just answered my question when your last sentence. Independent of smoke, of whether they're
Yeah,
associated with
so
smoking.
things that they don't associate with smoking. And take pictures of those things. And those pictures are what they're then going to be shown in the scanner, as well as standard rewards and other sort of non-rewarding environments that they're also going to take pictures of. Again, we will send them to go home to go take a picture of their stapler, or find some other way to have a kind of neutral control in that context. What's neat about this study is we're going to show them the pictures in the scanner during withdrawal, during satiation, just like we have for the other studies. But we're also going to do a withdrawal manipulation in the real world. We're going to have them smoke those nicotine cigarettes or those denicotinized cigarettes over the course of a week. And during that time, every morning they're going to get, do you expect to get out into nature today? How much do you expect to enjoy it? Every morning. In the evening, did you get out into nature today? Did you enjoy it? We get both that sort of anticipation of that reward, as well as at the end of the day, that the consumption, was it actually as good as you thought it was going to be? And we're able to do that both in the MRI scanner and out in the real world, and we're going to try to yoke the two of those things together to try to understand how those co-vary, how those are linked, and look at, okay, if you report that generally speaking, you really enjoy talking to your best friend, and a picture of your best friend lights the brain up in this region, does that response predict what you actually are doing in the real world? Believe it or not, this is not something that's been studied. It's trying to link what we're seeing in the scanner with that immediate real world response that's occurring is not something that's done. So hoping that we'll one, be able to kind of narrow in on appropriate paradigms for doing this. Question?
Is it possible when you look at this and marching into this set of studies that you might take things that they scored high on for enjoyability or what they like to do and somehow create a code that represents the difficulty in smoking at the same time they were doing this activity? So I'm making this up as an example. Let's say they say that they like cooking. And I'm not a smoker, so I could be making this up, but let's say it's rather difficult to be smoking a cigarette while you're cooking because you're paying attention to your pots and pans and you don't want the ashes to fall in your pot. Did you follow me? And there might be other things where it's really easy to smoke, where you're saying it's enjoyable for me to be on a bench with a friend of mine. It would be really easy to smoke all the time that you're sitting there. So is there any way to weight each of those the highest enjoyable activities by relative difficulty in being able to smoke simultaneously at the same time?
Great question. And I think we're doing that in a very crass way, so if I back up a little to the questionnaire, the final question either is whether or not this is associated with smoking. I would expect that that's going to be strongly, that it's probably pretty dichotomous, I guess, for individuals either, yes, I can smoke while doing this, or no, I can't. I don't think there's going to be too much of a continuum there. But that said, you very well may be right that there are, there might be those activities that are a little bit more mixed. Cooking is a good example where, you probably could smoke while you're cooking. It might be a little bit more difficult, uncomfortable, a little bit more challenging. So there might be some more nuanced ways of kind of breaking that down.
So for the future, would you be also comparing social activities versus individual activities versus activities?
Yeah, so part of the motivation for this is there are really no less than 50 separate exploratory studies we can absolutely want to break it down by social, non-social, and all sorts of things.
And you said you're using at the session where they get the MRI, seeing the photos as a predictor of their ratings of pleasure during eating.
Okay. So some kind of big picture discussion here in terms of ways to expand this. So I spent a lot of time talking about nicotine withdrawal, other sort of nuanced effects very early on. But also want to think about ways we can expand this more broadly, understanding all of these different factors that could play a role in driving this. At both the individual level and the environmental level. To what extent does the built environment, family and peers, all of these things impact this system, and try to focus on this as a system as much as possible. So, broad implications, things to think about, active control conditions, I already talked a lot about, but I think it's really critical to start integrating those more in these larger, more, they provide different sources of information and things we're doing. As much as possible, like I just said, trying to start thinking of these three components as an integrated framework, understanding how all of these things relate to one another, and looking at how things impact this system rather than treating these as separate individual components. And both decay and some of the other applications that I've submitted are trying to figure out ways that we can realistically achieve that. I think optimal designs in the laboratory need to start including more personally relevant context, personally relevant stimuli. Clinical implications. What does all of this mean in the clinic outside of this? I spent really an inordinate amount of time in treatment, focusing on drug reward itself. I've worked in, I think now, I'm a clinical psychologist by training. I've worked in, I think, 5 different substance use clinics at this point. And we spend probably 80–90% of our time talking about drug reward and how we need to, how are you going to cope with cravings? What are you going to do here? Oh, this is a high-risk environment. Let's figure out ways to avoid that. Spend very little time talking about things like what else is going on in your life. How can we make it so that life in general is appealing? And will that lead to you being less likely to use drugs in the future, less likely to be interested in it? Again, thinking of back to that rat park study, on its face, it's I think a very important and a very obvious way to approach this. But it's not what's being done in the clinic, it's not what's being done in the lab. Also, some work being done with decision making now, but it's something that I think has been ignored for far too long. Need to evaluate to what extent existing treatments are doing this. Need to come up with ideas for ways to expand our portfolio of treatments and integrate with some of this to better address these other components. Policy, same thing. We've focused so heavily on things like warning labels when it comes to cigarettes. Well, that's important. I think there's ample reason to do so, but at the same time, there's a whole basic science literature out there looking at how and why individuals become, basically the role that things like working memory load, perceptual load play in driving impulsivity and causing individuals to make worse decisions, make different decisions than they otherwise would. So by even asking simple questions like how we can modify the product displays without actually even changing what's there, without redesigning cigarette packages or anything like that, can we help people make better decisions? What alternatives can we put there? Does it change things if the cigarettes are being presented alongside the e-cigarettes or the nicotine patches or whatever else, if that's all being displayed in one location at the same level? Not research that I'm seeing done very often, even with this increasing focus on tobacco regulatory control. This is complicated stuff, and I think that's part of the reason why I'm not seeing this done very often. There's a lot of important lessons to learn from, I think, cognitive and affective neuroscience when you're doing this type of work. But we've been very focused on just sort of looking for those simple, that clear, policy intervention that we can say, we're like, okay, we're going to replace, the textual warning label with the skull and crossbones on it, or whatever else, and hoping that that's going to be, some magical cure that's going to have a, public health impact. And I'm sure that it will. I'm sure that, broadly speaking, we're going to make a difference by doing that. But we're not going to end smoking by making those single microcosm changes. We need to start thinking big. We need to start understanding how all of these pieces fit together. And that's really my take-home message for everything I'm presenting on today. So that was a lot, and I know I'm already a little bit over time, but thank you all for being here.
We do have the room until 1:30 if there are questions and people want to.
Anyone questions?
I'm just going to feel the number of
Yeah.
I have a question about your pay. So you had said that you're doing all the things that just aren't related to smoking. Is there a reason you're not looking at the things they find pleasurable that relate to smoking as well?
Now, I've gotten that question before. Really, it's largely a logistical decision about I can't afford another hour in the scanner. So I may pull that into like a separate behavioral task and try to develop some sort of reaction time or other sort of assessment we can use to get at exactly that issue. Because I think that it's really important to understand how those things fit in.
But you can also assess it in the EMA, or you're not assessing it in the EMA either, are you? Or
No, we're not. Actually, we could. I've been so focused on trying to keep the EMA and the FMRI as parallel as I can, but yeah, there's no reason we couldn't. really excited about it because you can actually get a picture of your brain at the end. That's part of our incentives. So people get super excited about that. And yeah, I mean it's a very safe procedure as long as you don't bring any metal into the scanner. So overall, people don't seem particularly concerned. I mean, we do have to rule out some folks for claustrophobia or if they have metal implants or other things. But generally speaking, like in a normal healthy sample, it's not too much of an issue. Folks I know that try to do it with kids, it can be a bigger problem because you go in this hospital setting in this dark, noisy room with a machine that's going to be banging while you're shoved in a cardboard tube. It's not the most comfortable place in the world. But yeah, no huge recruitment problems for these types of studies.
Yeah, and I think that you're showing the pleasant event scale, right?
Yeah.
Yeah. And so we've done like several papers with that, and a couple times now the reviewers want to know what rewards are most robustly, alternate rewards are most robustly like protective or associated with. So Meryl was asking like the social versus the non-social, right?
Yeah.
If there's any way you can try to build that into the design somehow, like having like a nested, like have two types of rewards. So when you bring it into the scanner, you have like a hidden factor or whatever that you care about, but
Oh, I see.
you know what I mean? Yeah, just if you could try to, or at least classify them. You can probably classify them post hoc and code them.
So that's the plan. Is we're
Yeah.
going to classify and code them, and then look at that as a covariate. And we did think about essentially that type of design where we're going to try to bucket these and have individuals like, okay, you can, we'll select your top 3 from this category, this
Yeah.
like umbrella category, this umbrella category,
Mhm.
and those categories might be social performance, whatever it might be.
Because if you're going to say like, oh well, for behavioral activation, treatment, well, look what we found. Like in the field and like in the scanner in your brain, we generally see it's not the same. It's not for everybody, but like this reward seems to be really popular or really robustly affected by withdrawal and may drive relapse. And I think the social thing is key, and I think that that's potentially some of the reason why AA works so well is the social reward, and it's a robust reward that we can't equalize, or we can't find that one that's that strong in amongst other types of rewards besides drugs,
Yeah.
right?
Yeah, the cohesion in a typical AA group is very different than it is in just a typical intensive outpatient substance use treatment program. And I think that's absolutely right. That has potential to be a significant driver of the effects that we see.
So just to clarify, if they rated like the 3 top activities or different top activities, those could be all social or those could be all individual. You wouldn't expose them to both individual or social.
That is the plan as of right now, but has me rethinking whether or not I do want to move forward with trying to kind of have. I'll need to figure out the best way to split it up. We just do something like that a little bit more, but have 3 or 4 different buckets, I guess, that represent different facets of the word. Anything else?
Are there any particular characteristics about Durham as a location that may make it difficult for these conclusions to be applicable to other cities like LA or even like internationally?
I was waiting for that question. So yeah, I mean, there's obviously tons at this point. I mean, in terms of things like, like the pharmacology studies are the pharmacology studies. I wouldn't expect those to, I don't think nicotine withdrawal here is a different experience than it is in Durham. In terms of the environmental studies, absolutely. I mean, the differences between Durham and LA are profound, and I live really far away in Durham from Duke, and that's actually like a 20-minute drive. It's the setting is obviously our downtown is kind of a proper downtown, but again, not like LA downtown, and it's in general much more rural. The number of tobacco retail outlets there, if we now, but you can see there's parts of the country where there's just nothing. There's really like just farms. So it will absolutely impact, the results that we're seeing there. We do have applications in to try to get follow-up funding to run, not necessarily with the imaging component, but a comparable study in a more kind of rural setting, and contrast that with downtown, with just sort of the downtown core of Durham to try to understand, okay, as best we can within that region, are we seeing, effects of rural versus urban? And I suspect that we will, but I obviously don't know what that will mean.
Okay. Thanks, Jason. Yeah.
By the way, I just want to ask your something in regards to this. I know, these are small things, but I'm really excited.
Did you guys meet on that?
No, it's
Okay.
okay. That's why I had so many ideas and then
When are you supposed to meet with them?
2:45.
2:45, okay.
I don't know.
You need to eat, right?
I don't have
So,
No, I wasn't eating. I was
but why don't you guys eat and then just chat a little bit?
We should involve in the strip paper, the tobacco abstinence.
You mean like the
The
discrimination?
intentional, the intentional processing, because we did a paper on.
Sure, yeah.
I want to
Sydney, did they
talk
show you
about-
how to
oh,
shut
I
this
think
off?
I'm
Yeah.
thinking about it.
Sydney?
Okay. Well,
Did they show you how to
we're trying
set
bring
this
them
up?
in